Now, the last thing we will talk about, I'm not going to show you why this works proof-wise, is because it's very in-depth and not really obvious why it works. So I'm just going to skip the proof part of this. But it's called the Triangle Angle-Bisector Theorem. It says if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. Holy crap, what on earth is that even saying? Am I talking English? Don't know. Let's translate what this is telling us mathematically with this picture here. Number one, if a ray bisects an angle of a triangle, here is our ray, AD, and notice it is bisecting angle A. Notice the two congruent segments there. So CAD is congruent to BAD. So here's our ray bisecting our whole angle. Okay, part one done. Now what? It divides the opposite side. Our opposite side would be this, would be CB. It's dividing it into two segments, okay, CD and DB, that are proportional to the other two sides of the triangle. The other two sides of the triangle are AC and AB. Now there's one of two ways we can set up our proportion, okay? I'm going to show you one way. Really, the way they present it is the other way. Now, I don't call this a triangle angle bisector theorem because it's a mouthful. I call this the Heart Theorem. And you might ask, why on earth are you calling it the Heart Theorem? Because what I do is I start at the bisected angle. I start here, and I wrap my way around going this way, and I wrap my way, I'll use a slightly different color here, wrap my way around going this way. And these two sides that I went through, AC and CD, I can set up as one ratio. And I can set it equal to the other two sides that I went through on this other side. Okay? So I can say that AC over CD, which again are these two pieces here, and I started from my bisected angle, so I hit AC first, CD second. So I wrote AC first, CD second. It's going to be proportional to, again, starting back at the bisected angle, going through AB over finishing it off with BD. And now I can cross multiply and solve, whatever values are in there. That's the way I look at this particular theorem. The way really it's saying is that these two pieces set up, CD over BD. Okay, so this represents the left segment, if you will. This represents the right segment, is proportional to the two sides of the triangle. Now here's the thing. CD, we said, was the left segment. And so since it's my numerator value, I technically need to use the left side that is adjacent to it. So this would be AC. BD was my right segment, so I need to match it up with the right side of the triangle, which is AB. Now, is this any different than what I just showed you earlier? Well, let me redo the Heart Theorem here. The Heart Theorem I said was AC over CD is equal to AB over BD. Okay, this was the Heart Theorem. Then this is technically what the Triangle Angle-Bisector Theorem is setting you up to do. Are these two different things? No, they're really the same thing. And how do I know that? Look at what happens when you cross multiply both of these. The AC gets multiplied with the BD. Does that happen here? Yeah, the AC gets multiplied with the BD. It works out. CD here gets cross multiplied with AB. Same thing happens here, just in a different order. Okay, so you can set this up one of two ways. And the only way you can really screw it up is if you take, a left piece and try to match it up with a right piece. You can't do AC over DB is equal to AB over CD. You can't mix and match your two pieces here. The ray is really dividing the triangle and saying this stuff over here can match up with this stuff over here. That's the way I look at it. That's where I get the heart from. So starting at the bisected angle, wrap around this way, you get one ratio. Wrap around the other way, you get the other ratio. Set them equal, cross multiply, done. So here's one example, example 3. Here's my bisected angle. So you got to make sure this is happening, that there is an angle being bisected. I'm going to wrap around this way. So I'm hitting 16 and 6. So there's one ratio. And if I'm going to wrap around the other way, I'm going to go through the x and then the 7. Cross multiply. We're going to get 6x equals 112. Divide both sides by 6, and I get, let's see, 16 for x. And that's it. Now, keep in mind, this 16 and 6, I'm going to backtrack just a little bit here. The 16 and 6, I could have simplified that fraction before I cross-multiplied. I could have recognized that really, 2 can go into each of those numbers, and I could get 8 thirds. And then cross-multiplied with that, and I'd get 3x equals 56. And I get, let's see, 1, 2, no. What did I do? What did I do? What did I do? Apparently 112 divided by 6 wasn't. 112 divided by 6. Yeah, wasn't 16. My bad. This ends up being 18 and 2/3. So backtrack that. When I had the original 6x equals 112. 112 divided by 6 is 18 and 2/3. AKA it's 112 over 6, which if I divide both those numbers by 2, I would get, let's see, 112 divided by 2 is 56. 56 thirds is also the same thing as 18 and 2/3. So sorry for the mistake, my bad. Example 4. Same thing we're going to do here. I have a bisected angle from a ray here, so this is the Heart Theorem. I start here, I'm going to wrap around this way, start here, restart there, wrap around this way. Now, this one's a little bit different because the 10, notice, is all the way across, and I really need to know what these two little sub-pieces are. Well, I know one of them's x. Well, how big's the other side? Well, if the whole thing's x and this piece is x, or if the whole thing is 10, sorry, and this piece is x, this must be the leftover of the 10 from the x. So if I took the whole thing 10 and subtracted away this piece, this is 10 minus x. There's nothing I can really do with that. Notice the 10 minus x piece plus the x piece. Notice the x's cancel out because I got minus x plus x, and I'm left with 10, which is the whole stinking thing. So now I can set up here and say 6 over its little segment piece, which is 10 minus x, is equal to the other way around would be 8 over the x. Can I simplify anything before I solve? Not really. Cross multiply, just make sure you distribute with the 8. So I get 80 minus 8x equals 6x. Add the 8x over, and we're going to divide by 14. So let's see, I don't think this really comes out to be, again, a whole number. No, so we're going to simplify this. So what can go into 80 and 14? Well, we can always start with 2 since both numbers are even. And we get 40 over 7. Can anything go into 40 and 7 besides 1? No. There's x, 47ths. Now, it is also equal to 5 and 5/7, but how would I prefer you write your answer? Just leave it as 47ths. Don't give me the crazy decimal, because if you put this in your calculator and do 40 divided by 7, you're going to get 5.714285714, and there's really going to be no end to that decimal. Don't round it. Give me the exact answer. Give me the fraction, preferably the improper